Okay, so here we go. We are going to look at a new lesson today. Students will be able to graph and solve systems. We're getting into systems today, and I'm going to show you what those are. Systems of equations, two or more linear equations using the same variables. So it's just like having two lines that are straight, okay? Two straight lines. You can solve them by graphing, and that's what we're going to look at today. You just see where those lines cross. You can do it by substitution. We're going to do that later, and elimination. We're going to learn that later as well. A solution is where those lines cross, okay? Or it's finding out what x is and what y is in both equations. It's going to have to be the same number to make both equations true. The intersection is the place where the two lines meet, okay? That's called an intersection. One solution means that they intersect only one time. There's only one answer. Infinite solutions means that these two are the exact same equation. It's one line on top of the other. That means it's touching an infinite amount of times. So it's constantly touching forever and ever and ever. No solution means that they never ever touch. So this means that they are parallel lines. They have the same slope, but they're never going to touch. Okay, that'd be no solution. Independent systems, okay, are a system of equations that has only one solution. Dependent systems, a system of which equation can be derived from the other. So same line, okay? Consistent system, a system of equation that has at least one solution. So the infinite solution is also consistent. Inconsistent is when there is no solution. So it's a lot of new vocabulary. You'll learn it over time. Let's get to the worksheet for today. First off, I want you to put your name on it. I get a lot of papers with no names. Put your name on it. Okay, so the first question, what is a system of equations? It's two or more equations. Two or more equations. What is the solution to a system of equations? It's a point that satisfies all equations in the system. Okay, a point that satisfies all equations in the system. So now let's look at types of solutions. We just kind of went over this in the vocabulary. Different types. Right here, where they intersect one time, that is one solution. Okay? Right here, they never ever touch, so this would be no solution. Okay? And this one, it's one line, but it's actually one line right on top of the other, so this would be infinite solutions. Okay? Now, make sure the equations are in slope-intercept form. Okay, so that is y equals mx plus b. It's on your formula chart. Always make sure they're in slope-intercept form before you graph them. Okay. So I'm going to do number 1 and 2 for you, and then we're going to look at the back side. Let's see if I do any with you on the back side. I may not. I may just let you handle it on your own. Okay, so let's look at number 1. Number 1, we have y equals 1x minus 8. So you start off with the y-intercept. Okay, you go down 8. 1, 2, 3, 4, 5, 6, 7, 8. If you don't know how to graph yet, you've got to learn today. Okay, so this one slope is technically 1 over 1. Okay, so we're going to rise 1 over 1. 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 Because it's going positive. So that means as you read it as like a book, it should be going up. Is that true? Yes, it is. Okay. Now, the next one. Y equals negative 2x plus 1. Negative 2x plus 1. So we start off with a y-intercept at +1, go to +1. Now, this is a negative 2x, which is a negative 2 over 1, right? So that means reading it like a book, it should be going down. Rise 2 over 1. Rise 2 over 1. Rise 2 over 1. Rise 2 over 1. We're going this way because it's negative. Down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. Okay? All right, so now we're going to find where they cross. So where do they cross? Right here, right? X first. 1, 2, 3. And then the y. 1, 2, 3, 4, 5. So it crosses at 3, 5. Or 3, negative 5, sorry. Because it went down, sorry. 3, negative 5. Okay, so let's look at number 2. Y equals 1/2 x plus 9. What do we start off with? That plus 9. So we go up. 1, 2, 3, 4, 5, 6, 7, 8, 9. The slope is a positive 1 over 2, right? So it should, as you read like a book, it should be going up. Rise 1 over 2. Rise 1 over 2. And then go backwards. 1 over 2. 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 Okay? Connect those dots. The next one. Y equals negative x plus 6. Well, we start off with that plus 6. 1, 2, 3, 4, 5, 6. Okay, plus 6. Negative x is technically a negative 1 over 1. Okay, so as you read it like a book, it should be going down. Rise 1 over 1. Rise 1 over 1. Rise 1 over 1. Rise 1 over 1. Okay. Now we need to see where they cross. So they cross right here at this dot. Always do x first. It's a negative 2. And then the y. 1, 2, 3, 4, 5, 6, 7, 8. Negative 2, 8. So this would be your solution. The x would be negative 2 and the y would be 8. Okay, so that's what you're going to do for the rest of this paper. Okay, you're going to go to the back side. You're going to graph the lines. Okay, now keep in mind this is not in slope-intercept, is it? So you need the steps. Move the x and it changes the sign, and then divide by y. Okay, move the x, divide by y. Remember, when you move the x, it changes the sign. If the y is a negative, be sure to divide by a negative, okay? All right, so you're going to do the rest of this worksheet. Be sure to submit your answers online. If you do not graph your lines with their individual points, I'm not talking about just that doesn't count. You must have their individual points. If you do not, you will not get credit for this worksheet. So be sure to graph all of your lines and give me the solutions. You can submit them online. Let me know if you need any help, especially with graphing. You must know how to graph at this point in life, okay? You've got to know how to graph. All right, good luck.